Hello everyone, welcome to part 2 of this video. So what we're going to go ahead and do now is review a little bit about our characteristics of functions. So what I want you guys to do right now is to think about which one of these functions is one-to-one. So keep in mind, when we talk about one-to-one functions, we mean a function that passes both the vertical line test and the horizontal line test. So I want you to go ahead and pick which one of these functions passes the vertical line test and the horizontal line test. So go ahead and give that a try. Okay, so we have these right here. We can see that part A, multiple choice A, is an absolute function. So this passes the vertical line test. So indeed it is a function. It's a function. However, when I go ahead and check for my horizontal, I can see that it touches twice horizontally. So unfortunately, A is not one-to-one. Okay, how about B? Does this function right here, and I'll go ahead and trace it out, does this cubic looking function, does this pass the horizontal line test? So hopefully you're able to see that, hey, it does not. This actually touches max at three places, right? We can go ahead and pick it right here. It touches at 3 places. So this is not one-to-one. Okay. This right here, we have the 1 over x squared. So this looks like our parent function 1 over x squared. And we can see again, it does not pass the horizontal line test. But for choice D, we have that it does pass a horizontal line test. So this is, yes, a function that is also one-to-one. Okay, so hopefully you remember that the reason we check for functions that are one-to-one is that if a function is one-to-one, then there is some such function, g of x, that is its inverse. So this is very important. So for this example, we have that this exponential does indeed have an inverse, and we can already remember from our unit that that should be a log function. Now, what we're going to go ahead and try next is finding symmetry of functions. Now, the way we do that is we evaluate the function with a negative x, meaning we substitute a negative x into all the x's and simplify. If the function that we get as a result gives us the original function, then it is even. If the function, after we substitute negative x, gives us all our signs, all the signs have changed, then we have an odd function. And if something else happens where it is not even, not as odd, then we say it is neither. So go ahead and substitute, evaluate x cubed minus x in this form. So negative x cubed minus a negative x. So go ahead and simplify. Will this give you an even function or an odd function? Okay. So hopefully you were able to give this a try. We have negative x cubed. That's the same thing as saying negative x times negative x times negative x minus, remember here we have a negative times negative, so plus x. And we can simplify all of these. It's going to be negative times negative times negative. That is negative. And then x times x times x. That gives me an x cubed. Don't forget about this little guy plus x right here. So we have our original function was f x cubed minus x, right? This was our original f of x. In this case, we have this new function, which we go ahead and say is f negative x. So are these the same? Is this one the same as this one? Because if they are, then they're even. In this case, you can see that they are not even. Are they odd? Well, in order for them to be odd, all the signs must change. So we can go ahead and see that in this scenario, we had a positive cubic that turned into a negative cubic. So far so good. Then we had a negative x that turned into a positive x. So in this scenario, this has symmetry that is odd. Okay, so very quick check. If you substitute and it gives you the same as the original, it's even. If you substitute negative x and all the signs change, then it's on odd. Okay, let's go ahead and try one more. When finding the inverse, we go ahead and swap our x's with our y's, and we go ahead and solve for y. Okay, so go ahead and pause the video and give this a try. So we have f of x is equal to the square root of 2x plus 1. We're going to go ahead and rewrite this so it could be y equals the square root of 2x plus 1. And remember, we have to swap. So now this is equal to x is equal to the square root of 2y plus 1. I'm going to go ahead and solve for y. So we square both sides to get rid of the square root. So let me go ahead and do that. So we square both sides. We have x squared is equal to 2y plus 1. And I'm just going to go ahead and solve for x. To get rid of the plus 1, I subtract 1 on both sides. So we got x squared minus 1 is equal to 2y. And to simplify y by itself, I'm going to divide by 2. Divide by 2. So my answer should be y is equal to x squared minus 1 over 2. Keep in mind we're going to rewrite it. So f inverse is equal to x squared minus 1 over 2. So we should have the following solution being here. X squared minus 1 divided by 2 for our inverse. So far, so good. Okay. So for this one right here, when we want to find the domain of a function, the first thing I want you to go ahead and recall is the little template that I showed you guys in class, which we did for the do now. So a function that is in this form, a rational function, has holes if we have the factors repeating on the numerator and the denominator. We have vertical asymptotes in the denominator for the factors that make this function equal to 0, and we have x-intercepts for the factors in the numerator. So the first thing I want you to go ahead and do is factor out the given function. Okay. So we have x divided by x squared minus 5x. So go ahead and factor this. What would be this in factor form? So hopefully you're able to see in the denominator, we have x on both of these terms, so we can factor out an x. So it'll be x minus 5. Okay. Alrighty. Now, hopefully you're able to see that, hey, we got the x's repeating right here. So we have a hole at x equals 0. And this part right here is going to be a vertical asymptote. So let me go ahead and make this a little bit prettier. So we have a vertical asymptote at x equals 5 and a hole at x equals 0. So our domain for this function right here would be all the numbers in the world, all real, except when x is equal to 5 and x is equal to 0. Okay, writing this in interval notation, we're going to go ahead and say that this numbers, it goes all the way to the left, so negative infinity, all the way to the next number that we have, which is 0. Then it's a hole, so it's going to continue from 0, then continue all the way to the next number, which is the vertical asymptote, which is 5, then 5 to infinities. Okay, so keep in mind, guys, the easiest way to do this is if you factor first. Okay, and then go ahead and use this template that we used to find holes, x-intercepts, and vertical asymptotes. The only thing you need to know is find out where your factors are and set them equal to 0. Okay, ready? We got one more. From this one, I showed you how to graph it with a table and realizing the parent functions. So I want you to go ahead and give these a try. Which one of these piecewise functions will go ahead and represent these graphs? Okay, So what I want you to go ahead and do is notice the intervals. So this right here are the intervals for each function. So we can see that, hey, x is less than -1. So from -1, and we can go ahead and label in all of these from -1, -1 is right here, -1 is right here. We can go ahead and see that our parent function here for x squared is going to be a quadratic. It's going to be a parabola upwards, right? Whenever x is less than -1. Now keep in mind, this has done a little bit of a transformation, right? So what we can go ahead and do is we can go ahead and substitute some values that is less than -1. So let's go ahead and do that. So we can actually put in a value. So let's say value less than -2. Let's go at x is equal to -2. That is a number to the left. So we can go ahead and substitute into the first function. So we got -2 squared plus 4 times -2. That gives me 4 minus 8. So that gives me a -4. So notice how this at -2, it is at height of 1. So this is most likely not going to be our answer. And then on this one, on B, we can see that when x is -2, we have a height of -4. So this is a possibility. By that same scenario, this is also a possibility because we have this point right here, 2 to the left and 4 down. And this is the same scenario as A. Okay. The next thing we're going to go ahead and look at is -5. A lot of students get intimidated, but this -5 is going to exist from -1 to 3. No questions asked is going to be of a -5. So a height of -5. So it's going to be a horizontal line. Keep in mind this right here, this inequality tells me it is open. And this inequality with the bar tells me it's a solid dot. So we're going to go ahead and check. And for both scenarios, you can see that, hey, look, it's the same for both, matching with our description. Okay. Last but not least, we have this function right here. 2 minus x. So what type of parent function does this remind you of? Hopefully you said linear, but this minus sign tells me what? That is actually going to have a slope that is negative, right? So notice how this slope right here, it's increasing. So there's no way this could be. This is our only option. This is 2 minus x. And of course, you can make a table to go ahead and match this out. It should work the same. And then we found this quadratic, and by substituting a point. So this should be our best bet. Okay. All right. Last but not least, we're going to go ahead and give this one a try. So if I told you x cubed is a transformation that is here, and we have this following transformation, so -1/4 x cubed plus 3, what are the transformations that occurred? If we have this little negative sign, we have this 1/4 and this +1. So go ahead and tell me which transformations took place. Okay. So this negative sign right here tells us it has been a reflection about the x-axis. This 1/4, remember, if it's a number in front of the function, that could be some vertical stretch or vertical compression. Okay, so if it's a number bigger than 1, then it's a vertical stretch. If it's a number that is between 1 and 0, then it is a vertical compression. Okay, so this right here is a vertical compression. Okay, x cubed, this right here is a parent function. It's going to look like a little cubic, and the +1 means 1 unit up. Okay, so we're going to see that the only choice left would be D, vertical compression by a factor of 1/4. Okay. Alrighty, guys, hopefully that helped. Hopefully it wasn't that bad. Please join me in office hours if you do still have any questions. As always, guys, it's been a pleasure, and I will see you guys on the next video. Thank you. Have a bye.